Hi everybody, we're going to get started with the webinar now. So thank you for joining us today. This is Maximizing ROI using state-of-the-art data science techniques. My name is Caitlin Onbank, and I am a marketing statistician here at Salford Systems. We also want to thank the American Statistical Association for spreading the word about this webinar. It is being recorded for later use, so you will be receiving the recording in an email. And if you have any colleagues or know anyone else that might be interested in seeing this recording, please pass the registration information along to them. I'll be talking for the next 45 minutes or so about maximizing ROI, and then we'll take any questions if we have time. And if not, I will be emailing you the answers to those questions after the webinar. So a quick outline on what we'll be looking at today. I'll talk about what ROI is. A lot of you may already know since you signed up for this webinar. It's a pretty broad definition we'll be going over just to kind of get an idea of how it will relate to the problem that we'll be applying it to. And then we'll take a look at that problem, which is Walmart store sales from a Kaggle competition. Then I'll be going over some data science techniques that we'll be using to build a model with this data. And finally, we'll just go over the conclusions and how we were able to maximize ROI with these models. So what is ROI? As I was kind of researching ROI for this webinar, I came across a lot of different interpretations and definitions for ROI depending on the industry and the end goal of what you're trying to do, either with your business or your business problem. So a definition is that ROI, return on investment, is a profitability measure that evaluates the performance of a business by dividing net profit by the cost of the investment. So we have some equations here. Net profit over investment, and net profit can also be expressed as the return minus the investment. So just a small example, if you have a project that you invested about $300,000 into, and you calculate the return on that investment, you're getting about 33.33%. Now, like I said, there are a lot of different equations depending on the business and the industry, and so this is just one example. And a procedure to improve ROI is you want to define what your return is. And we have that highlighted in red on this slide because that's what we'll be focusing on in this webinar, is maximizing your return, which will in turn maximize ROI. So by calculating this return, you can attempt to increase your net profit, and then that's when you kind of reevaluate your expectations and try and improve ROI based on whatever business or industry you're in. Like I said, we'll be focusing on return in this webinar, which will be total sales at Walmart. So this problem was taken from a Kaggle competition. Kaggle is a website where they host competitions throughout the year. They give you data, and you have to build the best model that you can. And there are winners. We just took the data from this competition. The Walmart store sales data is from 2011 to 2012 at 45 different Walmart stores across the country. And there's information on 5 different markdown promotions throughout the year. So Walmart puts on these 5 different promotions, and they want to know which ones are going to be useful to them and how. So our goal for this webinar is to use the weekly sales data to optimize these promotions, which in turn will maximize revenue. So there are 3 questions we're going to focus on. The first one is which markdowns are worthwhile. There are 5, so we want to know which ones are the important ones to focus on. The second question is what values of these markdowns are optimal. And finally, when should these markdowns be promoted? So since we have about a year's worth of data, we want to know when throughout the year is the best time to promote the certain markdowns that we find are worthwhile. So this is an example of what our data looks like. We have 45 different stores, and this data is just an example of store 42. So if we start on the left-hand column is the store number. Then we have the date, and these are dates from September in 2012. We have the department number. We have weekly sales for that week in dollars. The next variable is whether that is a holiday or not, true or false. We have store type, which can be either A, B, or C. And for privacy reasons, Walmart did not release some of the variable definitions, so we're not actually sure what A, B, or C corresponds to. We have the size of the store, the temperature on the day that the weekly sales were recorded, the fuel price, and then in red we have an example of markdown. So there are 5 different markdowns in the data. This is just one example so you can see what it looks like. So the values are about 341, but we don't actually know what this value means. Again, for privacy reasons, Walmart decided to disguise the data. So we're not sure if this is in dollar amounts or what it means, but it will still be useful in our analysis. Then the last 2 columns, we have consumer price index and unemployment rate. For the purpose of this webinar and saving time, we did subset the data down to just Department 1. Since there were upwards of 100 departments, we wanted to kind of whittle down our data set and just focus on Department 1 across all 45 stores. And typically, Department 1 in Walmart corresponds to candy, food, and tobacco. So the next thing we're going to talk about are the data science techniques that we're going to use to build a model with this Walmart data. Typically, you might start with a traditional linear regression. It's a common first step in a modeling process. But we've found that sometimes standard regression can't handle missing values, nonlinearities, interactions, and variable selection. So we're going to be looking at 2 more modern data science techniques, cart decision trees and TreeNet gradient boosting. And both of these approaches will help address those 4 common problems that regression comes across. So first we're going to talk about CART. CART stands for classification or regression trees. And what CART does is it simply partitions your data over and over again to kind of create clusters of records that have similar characteristics. So if you see the tree to the right, the green nodes are what we call parent nodes, and the red and blue nodes are terminal nodes. And so, for example, that very top green node is where all of our data starts. And what CART does is it finds the best split to partition that data into 2 different parts. And then it keeps doing that to build a regression tree. And we're using regression trees in this case because weekly sales is a continuous response variable. And the cool thing about CART is it separates the relevant from irrelevant predictors for you. You don't have to do this. It's automatic. You get simple and easy to understand results in the form of a tree, such as the picture to the right. You don't have to transform variables by hand. And outliers and missing values aren't going to affect your model as it might in a traditional regression. So CART is fast, and it was once known as the most versatile predictive algorithm available to analysts when it was first introduced. And it also provided the foundation to the modern techniques such as bagging and boosting. So CART is a great way to do automatic variable selection and get a quick look at your data, see if there are any red flags such as missing values or outliers. But there are also a few cons to CART, such as sharp decision boundaries and difficulty capturing a global effect, since it's mostly focused on local effects. So to fix those problems, we're going to then look at TreeNet. Now, TreeNet is also known as stochastic gradient boosting. It's fast, and it's typically more accurate than CART. And TreeNet works as an ensemble of trees. So this means that you build multiple CART trees, and the hope is that more trees are better than one. So TreeNet is a bunch of small CART trees built in an error-correcting sequence. So how this sequence works is you start with a small CART tree as your initial model. So in the picture, that would be tree 1. This is a small CART tree with 6 terminal nodes. You build this model with your data, and then you put your records back through this model and compute the residuals. So see how far off you are in your predictions. You then grow a second small tree, which is tree 2, to predict the residuals from that previous model. And you keep doing this for a minimum of 200 trees. And so in this way, you're learning from the previous tree, and it's kind of self-correcting itself. So this corrects the problem of global effects in CART and sharp precision boundaries. We're going to be looking at both CART and TreeNet on the Walmart data to see what we can learn about the markdowns and when we should promote them throughout the year. Okay, so the next step would be building a model. And this is a screenshot of our software. So I'm going to move over to the software now so I can show you firsthand how to use this data to build a CART and a TreeNet model. So on my screen right now, I have our software Predictive Modeler, which we call SPM version 7. This is the version you'll get if you do our 30-day free trial download. It's 30 days of a fully functional license, so you will be able to do everything I show you today, and we'll also be sending you a tutorial on how to replicate these steps. This is our GUI interface of SPM, but if you prefer to code from the command line, we do have that option here. We also have a non-GUI version of the software. The first thing I'm going to do is open up the Walmart data. We can take a look at it. There's a small folder icon in the upper left corner. If you click that, it'll open up a dialog box to locate your file. Here I've named the file department1.csv. We also support all different types of files. If you look in the drop-down menu, we have HTML, SAS files, Excel files. All you need to do is click open, and the file will be imported. And it'll see this activity window. And this is a good way to know if the file that you just imported came in correctly. You can see all of the variables listed on the left. These are the same variables I showed you in the slides, including the 5 different markdown values. To the right, you can see that we have about 1,400 records.
One last night. Would that have been the most recent? Or
weekly sales in Department 1.
Put it up today.
And we have 18 variables total. At the bottom of the activity window, we have a lot of different buttons where you can create graphs from your data. You can run statistics on your data, view the data, prep the data, set up some options for your data, or build a model. So before we get to the model building part, we're just going to click the View Data button. And this just brings up a spreadsheet of your data. You can take a look at your variables. It's a good way to quickly see if you have any missing values. Our date variable is now numeric for analysis purposes. As I mentioned, department is just going to be 1. I also want to point out one extra variable we added to this data set, which is called test. And The test variable takes on values 0 and 1, and when we set up our model and we set up how to test the model performance, I'll explain where this variable comes into play. So I'll just close out of the spreadsheet, and I'm going to reopen that activity window. A little shortcut at the top with the tools on it will reopen your activity window. So now we're going to click Model to open up our model setup. This model setup window is where all of our engines in the software can be set up. So when you import your data, you can just come straight to model setup, and you can run one of many different analysis methods. So here you can see we have cart, data binning, generalized lasso, logit, Mars, random forest, regression, TreeNet. Before we get started on a cart model, I want to run a standard regression. As I said before, this might be one of the first steps in your modeling approach, and I want to show that it doesn't do a great job with this data. So after you pick the analysis method, you want to pick the variables to include in your model. So if we scroll down and find weekly sales, we can select that in the target column. We can highlight this entire predictor column and select all of the variables. We do want to leave a few out, including the testing variable, since we'll be using that for a different purpose. And I also want to uncheck department, date, and case ID, because those won't be predictive in the model. Case ID is just a record identifier. So finally, we want to set up a way to test our model performance. So we're going to click the Testing tab at the top of the Model Setup window. Typically, we use the second selection here, a fraction of cases selected at random for testing, 20%. What this means is that 80% of our data will be randomly selected to build a model, and then the remaining 20% will be used to test that model's performance. In traditional regression, you usually use 100% of your data to build the model, but a more modern approach is to leave a separate test sample to actually see how your model is doing. The problem with this data is that it is time ordered. It's a time series data because we're using weekly sales from 2011 to 2012. So if we use a random 80% of the data to build the model, we might be using future data to predict past data. So it doesn't make a lot of sense. And for this reason, we have to introduce a new variable. So if I click this last option, variable separate, learn, and test, and select our test variable. And what this does is it takes the first 80% of all of the weekly sales values to build the model, and then it tests with the remaining 20%, which would be in 2012. So now that I've set up the variables in the model and the testing, I can click Start in the lower right corner to build the regression model. So what comes up is a regression results summary window. This gives you a lot of different summary statistics. So depending on what you like to use to evaluate your models, you can use either root mean squared error, mean absolute deviation. There's R squared, 36% for those of you who like to use R squared. And we'll always be looking at the model performance on the test sample. So this isn't a very good model, but we'll use it as our baseline, so we know that we can improve by using the other modern data mining approaches. So just keep in mind we're getting about 36% R squared, around 5,500 mean absolute deviation. So this is a dollar amount, or how far off we are in our sales predictions. So now we're going to run a cart model. So I'm going to reopen our model setup window, which we can get to via this blue and yellow web shortcut. So I'll come to this drop-down menu in the bottom right for analysis method and choose cart. We always recommend that when you're first looking at your data, it's always useful to run a cart model just to see which variables are relevant, see how the performance of your model is doing before you jump into any more complex algorithms. So now we have a choice for our analysis types because cart can also run classification trees. We just want to make sure that regression is selected. And our variables are still selected here from our regression model, so that's all set. We now have a lot more tabs at the top of our model setup window because cart is a much more complex engine than standard regression. We'll click the testing tab and make sure that our test variable is still separating our 80% model building sample and our 20% testing sample. The one other tab we're going to look at is the limits tab. Now, if you think back to the PowerPoint slide where I showed you the cart tree, I told you that cart takes all of your data and it starts partitioning it in half, and then it looks at each of those halves and it keeps partitioning. So hypothetically, you could keep splitting your cart tree all the way down until you have one record in each terminal node. So if you had 1,400 records, you'd have 1,400 nodes in your tree. Now this isn't very useful. It's not really going to help you with predictions or tell you anything about your data. So we want to impose some limits on that cart tree to make sure that it doesn't get too big and that it can still tell us something about our records. So in this first box called parent node minimum cases, I'm going to type in 70. And what that means is that no node can be further split unless it has at least 70 records of weekly sales in it. For terminal node minimum cases, I'm going to type in 20. And what this means is that no resulting node can have less than 20 cases in it. So if you're using cart to build clusters of your records, and you don't want any clusters with less than 20 records, that's where you would put this number in. So we've set up the variables, made sure the testing was the same, and imposed some limits on our cart tree. What we have to do is click Start to build the model. So what we get after running a cart tree is our cart navigator window, and this shows you the tree structure that the engine built. So in the top half of the navigator window, you get your optimal tree structure. The green nodes are your parent nodes, and the red nodes are terminal nodes. And in the lower half of the navigator window, you have your model sequence. So this plots the number of nodes in your cart tree against the relative error of the model. The green bar here denotes your optimal model, which is the lowest relative error. And based on which of these blue squares is selected, the tree in the upper half will change. So this is also a good way to see how cart went about building your model. If you select the two-node tree, you can see the first split that cart made. So what happened is in the green node, you started with 80% of your data, and cart took a look inside that data and found the best split point to separate the two resulting nodes into lowest mean weekly sales and highest mean weekly sales. And you can color code your tree too from this menu. And hovering over and clicking the nodes also gives you a lot of different statistics on the records that are in that node. And here we can see that the splitting variable was markdown 3. So all records with markdown 3 less than or equal to 560 went into this left node, which had a mean weekly sales of around 21,000. Everything with a markdown value greater than 560 went into this right node with a mean weekly sales value around 38,000. So cart kept splitting the tree because it wasn't finished yet. And so you can click along this sequence. And the reason we give you the sequence is both to see how it was created and to give you the option of choosing one of these smaller trees. Just because this green bar tells you the optimal model based on relative error, you might have a different performance criterion that you would like to use. So we're at this optimal model here. We can see to the right that there's an R-squared test value of 49%. So this is already a pretty big improvement on our regression model where we had 36%. To see information about which predictors were most important in this model, we can click the Summary button at the bottom of the Cart Navigator window. This brings up a similar display to the regression results window where we can see all of the different performance measures. We have mean absolute deviation around 4,300. And again, we have R-squared around 49%. One of the most important tabs in the cart summary window is variable importance. And sometimes this is one of the main reasons to run a cart model is to just quickly get a result and see which of your predictors are actually affecting weekly sales. Because we know we have about 49% R-squared in predicting with this model, but we don't know which predictors are actually playing a part. And so this tab will show you relative importance scores of each of the variables in your model. So for example, markdown 3 is the most important variable. Size is the second most important variable, which might be kind of obvious. The bigger the store, the higher the sales. Markdown 4 is third most important. And then you can also see that unemployment rate seems to be the least important. So we've answered our first question, which was which markdown promotions are worthwhile to take a second look at. And so quickly with the cart tree, we saw, okay, maybe markdown 3 is something that we should look further into. And so the second question was which values of markdown 3 are important. And that's what we'll be using TreeNet to find out. So I'm going to run a TreeNet model now. Open up our model setup window via the shortcut again. Going to change our analysis method to TreeNet. We still have our analysis type set as regression, and our variables are all still selected. We want to click the testing tab, make sure test is still separating our data correctly. And one more tab we want to look at is the TreeNet tab. Now TreeNet can be a pretty complicated algorithm. There are a lot of different parameters that go into building the model. So these can be confusing, and a lot of options in this tab have pretty good default values that will give you a good starting model. So typically I'll come in here and I'll run a TreeNet model with the default values, and then I'll take a look at that model and tweak the parameters afterwards. So we're just going to leave the defaults as is right now and press start to build our TreeNet model. So for building 200 cart trees, TreeNet runs pretty fast. And what we get is a graph of the number of trees in the model. So from 0 to 200, at each tree, the mean absolute deviation, or the mean squared error, you can change the graph. It's recorded at each model. And what this green bar here is telling you the optimal model is at 200 trees. Now this is kind of a red flag because the model might not be completely developed and reached an optimal solution if the optimal model is at the last tree. And as you can see, up here to the left, we have a R-squared of about 46%. Now this is worse than our cart model. So something tells us that we might need to build more trees. We might need a bigger ensemble to reach a better performance. So this is where those TreeNet parameters come in. I'm going to reopen the model setup window and go back to the TreeNet tab. Now there are a lot of different things to change here, but I'm only going to change 2 of them. First, we want to build more trees. So in this option to the right, number of trees to build, we want to change this from 200 to 500. So we're more than doubling the amount of trees in the ensemble in the hopes that we'll get a better model performance out of it. The other number I typically change is the learn rate. This is set at auto, so it's automatically calculated for you. What the learn rate does, without getting into too much of complicated theory, is it controls how fast or how slow your TreeNet model is approaching the optimal solution. So if you try to correct your residuals too quickly, you might be jumping between overfitting and underfitting, and it's not an ideal way to reach an optimal solution. So what we want to do is we want to slow this number down. Sometimes you have to build more trees because of this, but it's a better way to reach good model performance. So I'm changing this to 0.1, the number I like to try typically. But again, if you aren't happy with the model that you get, you can always come back in here and play with this number. That's all I'm going to change, so I'm going to click Start. Even with 500 trees, the TreeNet model builds fairly quickly. We're getting a much better graph here. We can see that the optimal model with the green bar is now at 369 trees. So it didn't even reach the full 500 trees before it got the best solution. And this is a good sign. We can now look further into this model by clicking the Summary button. We're seeing we now have an R-squared of around 62%. And compared to the standard regression model at 36%, we're pretty happy with this number. This is a really big improvement. And we're also getting mean absolute deviation around 3,300. You can also look at variable importance for the TreeNet model. Now, since you're building 500 trees instead of just 1, the variable importance is averaged over all 500 trees. So the numbers will change a little bit. As you can see, size is now the most important variable. But Markdown 3 is still pretty important at a relative score of 80%. You can also see that Markdown 2 has jumped up as an important variable. So maybe after you look at Markdown 3, Markdown 2 is something you would want to take a second look at. Okay, so I told you that we would be finding out which values of Markdown 3 are important to our model. And the way to do that is to create what we call TreeNet partial dependency plots. To create those, I will click the Create Plots button at the bottom of the TreeNet output window. This brings up a Create Plots dialog box. You can select whether you want 2D plots or 3D plots or both. For now, I'm just going to create one variable dependence plot, which are just 2D. Down here is where you can choose which variables you want to create plots of. And we're just going to use the top 3 variables for time-saving purposes. And this takes the top 3 variables from the variable importance list. So over here we can see that we'll be creating 2D plots of size, Markdown 3, and Markdown 2. I'll click Create Plots. And this will bring up a plot selection window. And this is useful if you have a lot of plots created. You can expand the list and pick which ones you want to look at. but for now I'll just click Show All. So these are TreeNet partial dependency plots, and what they do is they show the average contribution of each predictor to weekly sales across all values of that predictor. So not surprisingly, size looks like it has a positive trend. The bigger the store, the higher the weekly sales. But what we're really interested in is this plot for Markdown 3. You can double-click the plot to open it in a bigger window. And what we see is an interesting trend here. A very small value of Markdown 3 doesn't seem to have a great impact on sales. But as you increase, the contribution spikes at around a markdown value of 2,000. And then as you increase the markdown value, the contribution decreases. So this is telling us that maybe we should be focusing on markdown values in the 1,000 to 2,000 range. Additionally, if you want to take a look at Markdown 2, you can open up this plot. There are definitely more spikes and dips in the Markdown 2 plot, so that might be a little more complicated than Markdown 3. So now that we know that we want to focus on Markdown 3 in the $1,000 to $2,000 range, we are going to figure out what times of the year we should be promoting Markdown 3. And the way we're going to do that is we're going to score our TreeNet model. What this means is we're going to create predictions on our data set from this model. To do that, we're going to click the Score button in the bottom right of the TreeNet output window. This brings up the Score Data dialog box. So this first field, we have our data file, department1.csv, our growth file, which indicates which model we're scoring, which is just this TreeNet output one that we just clicked from. And we also want to save our scoring results. So I'll check the box next to Save Scores As. And this will allow me to name a new file. And I'm going to call it department1score1.csv. So I already have that in here. I'm just going to overwrite it. And then below that option, we have two options to save all of the model-related values and save all the variables in the data set. So this will just give us all the information that we need. There's some more options down here to pick target variables and weight variables, but we don't actually have to do any of that to get our scoring results, so I'm just going to click Score. So what this did was it just took our full data set and it ran it through our TreeNet model. So because we just created predictions on data that we also used to build the model, it's not surprising that we're getting a pretty good result here, about 84% R squared. So now that we have created predictions for weekly sales, this is kind of comparing to what you would do if you built a model and you wanted to know how your sales would do for the following year. And as maybe a store manager at Walmart, you might want to know how Markdown 3 is going to affect these sales. So we're also going to score this model again on the same data set, but without Markdown 3. So we know that Markdown 3 makes a difference, but we want to know what times during the year that it makes the biggest difference, or maybe even the smallest difference, so we can eliminate the markdown during those times. So I'll be opening a new data file, and I've named it Department1, No Markdown 3. So this is where we've zeroed out the entire Markdown 3 column, and we're going to score it back through this model to get new predictions of what the sales would be like if you weren't promoting Markdown 3 at all throughout the year. I'll go through the same saving process. I'll save it this time as department1 score2.csv. Also want to save all model-related values and variables again, and click Score. So here we can see our R-squared is definitely lower than the last, which is surprising because we're eliminating Markdown 3, and we know Markdown 3 is important. So we're not looking at model performance really right now. What we want to do is compare the two models to see what weeks during the year are most important to focus on. That brings me back to our PowerPoint slides where I can summarize this information for you in a table. We went ahead and built the model. And now we're going to look at some tables summarizing this data. This can be a little confusing. I'll walk you through what this table is telling us. We have the store numbers on the left, including all of Department 1. Now what we did was we built two models. So we'll call them Model A and Model B. Response A is a column holding the predictions of the weekly sales in that first model that included Markdown 3. So the column to the right is Markdown 3A. So those are the original Markdown values. Now response B is the prediction of weekly sales with the data that did not include Markdown 3, which is that last column. Shows Markdown 3B is all zeroed out. And what we did is we took the difference between these two predictions, and that's our difference column in the middle of the table. Then we computed what the difference rate was. So from response B to response A, we had almost a 200% increase in sales that we can assume or we can hope was due to Markdown 3. Another interesting thing to notice is the values in Markdown 3A are around 1,000 to 2,000, which we noticed in the partial dependency plot were very influential values. So not surprisingly, if you look in the date column of this table, this is a few days before Christmas. So this might not be very surprising to a store manager, but it also might validate the use of this markdown during this time. He might decide, okay, this is great. We're going to keep doing this next year for Christmas too, because it seems to be working and boosting our weekly sales. So this increase in sales corresponds to the return value in our maximizing ROI equation. And so if we can boost this value, we're hopefully maximizing ROI. Now we don't have our investment information. We don't know how much it costs these managers to promote Markdown 3. And so with that information, you would be able to compute the entire equation and see whether it's working out for you to be using this markdown at this time. Since this is such an improvement in sales, we might want to actually look at the times where Markdown 3 is not helping at all. And so that's our next slide, non-influential markdowns. Now we sorted this data set by the difference rate. So now we're looking at the bottom of the data where we have either a difference rate of 0 or actually negative, where the Markdown 3 was possibly decreasing our sales. Now, if you notice in Markdown 3A column, these are pretty small values of the markdown. So they might not have been helping because they were at such small values. So the manager can either decide that maybe he should bump these up in the 1,000 to 2,000 range to see if they'll help. Otherwise, he might consider just completely doing away with promoting the markdown at these times of the year. And if you look at the date column, some of these dates are in the summer, but they do seem pretty random. Week after Christmas, July, August. And so with the cost information on how much it costs to promote these markdowns, these might not even be worth it. He might just do away with this promotion during these times completely. So we learned that markdown 3 was influential. We learned that it might be optimal to set it around the $1,000 to $2,000 range. And we learned that Christmas seems to be the best time to promote markdown 3. So this is just a small subset of the data in Department 1, just looking at one markdown. For a 45-minute webinar, we couldn't really get into analyzing the entire data set, and the CAGO competition actually was just predicting weekly sales overall. So we took a little bit of a different approach, just to give you an example of how you can calculate ROI on just a subset of your data to still draw some insight. A few conclusions that we came across in the analysis today is that the markdowns have different effects on sales based on the value, based on the time of the year, and based on the other predictors in the model. We saw that traditional regression couldn't capture some of the nonlinearities as well as CART and TreeNet could. We decided that store managers could easily use this model and information to choose markdown value and choose a date to run the promotion. We also saw that we might have insufficient markdown data. We only have 1 year, and so it may not be completely reliable. So just kind of as a side note that you may need to include more than 1 year of observations for reliable models, but this was just what we could do given the data that we were given from the Walmart competition. Additionally, we couldn't really describe the markdown influence in dollar amounts because Walmart had disguised the data. But in this case, it's still useful in the analysis, and when you give the results back to the person that gave the data to you, they will be able to still draw insights from it. So all in all, this model can be used to better schedule promotions within each store or department for the following years. And we were still able to extract a lot of insight. The managers may have started off not knowing anything about the markdowns, whether they were working or when they were working. So this is telling us a lot more than what you would know if you were just randomly guessing. So there are many other applications that you can use these techniques. It's not just for ROI, and ROI is not just for Walmart sales data. So no matter what industry you're in or what field, there are a lot of different ways that you can apply these methods. So for example, in marketing, you can identify which customers to target, which would be the equivalent of identifying which promotions to use. And that would, in turn, increase your response rate, which would correspond to increasing our total sales for Walmart. So there are a lot of different applications. And if you're still sitting there wondering how this could apply to your field, we'd be happy to help you out with your data and figure out how CART and TreeNet or any of our other engines could help you. So before I take a look at the questions, I just want to remind you that you can get a 30-day free, fully functional evaluation of our software, SPM. You'll also be getting a step-by-step tutorial to replicate this analysis, along with a recording of the webinar. And we also have a lot of data science events throughout the year this year. We have mini trainings, and we also have full data mining training. So if you're interested in the theory and the concepts behind the software, we have 3-day trainings, including one in July that is held online, so you can watch it from your office or your living room. And we also have a lot of these webinars coming up. So if you want to visit our website, salford-systems.com, there's an events calendar with all of this information. If you have any other questions, you can email support@salford-systems.com. So I'm going to take a look at some of the questions. And if we can't get them all answered, I will email you the answers after the webinar. Okay, so one of the questions is about how variable importance is determined or calculated. So variable importance is calculated differently depending on which engine you're using. For CART, what happens is an importance score is calculated based on the improvement of that variable in the split it's used. So for example, if you're just partitioning your data into two parts and you use a variable, there's an improvement score that's calculated based on how well that variable is splitting at that split point. And so with TreeNet, all of these important scores are added up and averaged over the entire ensemble. So the theory behind that improvement score is a little complicated and something that we can definitely send you some more resources about after the webinar. Another question is, what is response Y? The response variable in the model was weekly sales for Walmart. This was in dollar amounts and recorded at each store and each department for every week. Another question is, in some of your models, the R-squared from the test data set was much different from that of the learn data set. Doesn't that indicate a problem with stability, even if test is greater than learn? The answer is yes, possibly. There's a lot of reasons that those two numbers can be different from each other. Since we are using time series data and since we don't have a lot of that data, this can be a reason for it. It really does matter on the data, what data you're using and which methods you're using. What are the differences between using TreeNet and random forest? TreeNet and random forest are both ensemble methods, so they are both using upwards of 500 trees. The only difference is that TreeNet is using a self-correcting sequence where I told you how it predicts the residuals from the previous tree. With random forest, it's just building CART trees on bootstrap samples, so you're not really learning from the previous tree. Again, that's something that we can send you more information about. Another question is, how can I see the final model other than the tree? There are a few different ways. You can translate the model, and this is another feature that is available on our output windows. It's next to the score button, and you can translate it into a variety of different languages such as SAS, C, Java, PMML. And this is a good way to look at the code to better understand the model that you built. Another question is, will this webinar be placed online for viewing? Yes, you will be getting an email after the webinar with the recording that you can view. Another question is the difference you calculated, the difference between the prediction with Markdown 3 and the prediction without it? Sorry, I wasn't following. Yes, that is correct. The difference is between those two predictions. The response variable was weekly sales at Walmart, recorded for every week at each of the 45 stores and departments. We have a few more questions about R-squared in regression, and we will answer these questions offline because they're a little more complicated and they depend on the data that you're using. So I think we'll answer the remaining questions offline. We have a lot of different resources that we can send you that will hopefully better answer your questions. So thank you for joining us. You will be receiving a follow-up email, and we encourage you to join us for the other webinars we have upcoming throughout the year. Thank you.